Hi, this is Arthur with a brief Tezos dev update. A couple of things I'd like to talk about this week. So I think Milo already mentioned a little bit contract literals. So a contract literal is a way of representing a contract inside another contract, inside the Michelson code, but not a contract that already exists on the blockchain, but one that you're building up. And so now you should be able to take one of those contract literal and actually have your contract create another contract. Another change in Michelson is the introduction of a big map. So this is something I've mentioned before, which is that in the current model for Michelson, you have to deserialize all of your data before you do any computation on it. And this is because we use type data, we use high-level data. If we had a model with a very low-level virtual machine that was just operating on memory, it would be easy to just memory map this thing, and then you would only pay for the operation that when they touch the memory or when they affect it. But here, the type safety that we require means that you have to pay this cost of deserialization. So that precludes you from having very large amount of storage into a contract. Now, there's a big use case for having contracts with large amount of storage, which is subtokens, what they call in Ethereum, the ERC20 standard, for example. Because in that case, you want to store a big map with a lot of, as a keys, you have a lot of public keys, and as value, maybe so you have something like an integer representing an amount of tokens. So this can take a lot of memory, and you don't want to be paying a gas cost of deserializing this entire map every time your contract is called. So one kind of killer solution for that I've been talking about at conferences before is the hash consing. So the benefit of the hash consing is that you're representing all of your data as a tree, and you're only really paying for any piece of data that you access. Now, this would be very efficient. And on top of that, it means that any shared data between contracts would only be stored once on a blockchain and once on the in a context. So very efficient, but tricky to implement. You need to do garbage collection. You don't want to be doing hash consing all the way to the like to single integers, for example. So we don't want to have that in V1, but we do want to be able to support subtokens. So the best compromise is what we're doing now called the big map. Essentially, it means that every contract is going to have a big map, and you can select the type of that map. So you just select the type of the key, type of the value. If you want to store different kind of value, you can make that with some type. And this is the difference with regular Michelson values, is that you're only going to pay the gas cost for the part of that map that you access. And that covers almost all the use cases. The main use case of having a subtoken is covered trivially. You map an amount to a key to an amount. But even if you want to have any more complex storage, then essentially you can implement hash trees, for example, on that structure and only pay for the pieces that you want to access. So if you really need to have a large amount of storage for a contract, you can use that big map. And internally, when you modify it within your Michelson contract, you will be dealing with a diff object that represents a diff between what the map is before you start modifying it and what the map is at the end. So that's for the big map. Other change I'm excited about, Vincent has been working on a BIP32 implementation for the ED 25519 signature. So BIP32 is a standard for hierarchical wallets. It's not trivial to do it for the curve 25519 based on the way it defines private keys. Essentially, in curve 25519, you start with a seed, you expand it, and then it gives you one part which is used for the signature and another part which is a private key. So that doesn't necessarily translate directly into BIP32. There's a paper that came out proposing a standard. It's the same standard that's being implemented by Ledger. And so we have that now in software in a camel as well. So that's exciting. So that's mostly all for this week. I think next week will be pretty quiet because it's the holidays and a few folks are going to be with their families. And in the meantime, we wish everyone a happy holiday or a Merry Christmas or whatever you celebrate. And I'll probably be back on this video next year. Until then, see you soon.